Welcome back, everybody. In this video tutorial, I'm going to talk about vertical and horizontal stretches and compressions. But before I begin, I'm going to briefly introduce two concepts that can help us distinguish between the kind of transformations that can occur to graphs. Now, in a previous video, we discussed how a graph can have horizontal and vertical shifts, as well as reflections. But these kind of transformations are called rigid transformations. The basic shape of the graph is unchanged. However, its position on the graph may shift a little bit. But in non-rigid transformations, on the other hand, are those that can cause a distortion. So the graphs may stretch or shrink a little bit depending on the function itself. Now, if you look at those guidelines here on the left, notice for a vertical stretch to occur, the coefficient in front of the function has to be greater than 1. While for the graph to compress vertically, the coefficient in front of the function has to be between 0 and 1. Now let's look at an example. Here we have our basic function is f of x is equal to the absolute value of x. And as we know, it looks something like this. Now we're going to try to graph g of x and h of x. Now let's begin. So I'm going to use green for g of x. We're going to go ahead and construct a table of values. Let's say here. So we have x, then we have g of x. Now if we use values like, let's say, -2, just to get a more accurate graph, -1, 0, 1, and 2. Okay, now if we take -2 and plug it into the equation, we're going to get 2 times the absolute value of -2, and then the absolute value of -2 is just 2, so 2 times 2 is going to give us 4. If we plug in -1, we're going to get 2 times the absolute value of -1. That's just going to give us 2. With 0, it's just going to give us 0. And then with 1, well, that's just going to give us 2. And then 2 times the absolute value of 2 is 4. Now let's go ahead and plot those points. We have, notice how the increments are by 0.5. So 0.5, -0.5, -1, and so on. We have -2 and 4. -2 is here, and then 4 is all the way at the top. So here. So if we go to the left here, -2, there's our first point. Let me make it a little bit clearer. Okay, we have -1 and 2. So -1, then we're going to go up to 2. That's our second point. We have 0 and 0, which is just at the origin. I'm just going to put a dot there. We have 1 and 2. 1 and 2 right there. And we have 2 and 4. So 2, and then all the way to the top of 4. Somewhere here. So there we have our points. If we go ahead and connect them, It's going to turn out something like this. Of course, this goes on forever. So like this. Now let's go ahead and graph our third function, which is h of x. Hopefully there's enough space there. Let's make our table of values here. Hopefully you can see that. We have x and h of x. So we're going to do the same thing. We're going to go ahead and put -2, -1, 0, 1, and 2. Now, half times the absolute value of -2. The absolute value of -2 is just 2, and then 2 times half is going to give us 1. Half times -1, absolute value of -1 is just 1, so 1 times half is just half. We have 0. Let me move this. 0, we have 1, 2. So half times 0 is just going to give us 0. And then half times the absolute value of 1, that's just going to give us half. And then half times the absolute value of... I keep running out of space here. Then half times the absolute value of 2, well, that's just going to give us 1. So there we go, we have our points, and we can go ahead and plot them. So at -2, we have 1. So -2, we have 1. So somewhere here, there we go. We have -1.5, so -1.5, which is right there. We have 0 and 0, which is the origin. We have 1.5, which is 1 unit to the right, and then half a unit up, so right there. And we have 2 and 1, which is 2 and then 1. We can go ahead and connect the dots. The function is going to look something like this. And of course, this is going to go on forever. Now, looking at both functions relative to the original function, which was f of x is equal to the absolute value of x, notice for g of x equals 2 of x, we have a vertical stretch. So basically each y value compared to the y values of the original function is just multiplied by 2. And you can go ahead and check by constructing a table of values for f of x here, which was the absolute value of x. I'm going to tilt the camera so that you can see this. There we go. And then similarly, if you look at h of x, which is half times the absolute value of x, we're going to get a vertical shrink where each y value of the original function is multiplied by 1/2. So I'm going to cover horizontal stretches and horizontal compressions in another video. But if you enjoyed this video, and would like to see more, remember to like it and hit that subscribe button. This is going to help grow the channel more. And don't hesitate to leave a comment in the comment section below if you have any questions or concerns. And we'll see you in the next video.